Yeah, I'm live streaming it. So you guys, this will be on the recording, but I'm live streaming it instead of recording it because it automatically records on YouTube when you live stream. Just a sec. Okay, yeah, it's going through. Okay, so again, today we're going to have a review over sections 3.1 through 3.4, which are the sections on this first test in developmental algebra 1. Okay, let me change this virtual background to no virtual background. Oh, how do I do that then? Okay, now we're back to my boring office. And then let's switch over to my document camera. Well, first off, any questions from the homework? Let's start there. Do you guys have any questions from, and it can be from any section, 3.1 to 3.4. Let me get my book out. Oh, it's right here. You can, oh, what's up? Did somebody say something?
Can you do number 11 on 3.2 from the
3.2. Okay. So first let's start at 3.2. Let me flip over to the document camera. Okay, so first we're going to start with 3.2 and the homework, number 11. This is on page 194, right? 194. Ooh, I like this question. Okay, page 194. And it says, find the slope of the line containing each pair of points. So we know we've got this line and it goes through -2, 5 and 3, 5. Right? So -2, 5 and 3, 5. So if we want to find the slope and we just have 2 points, we can do the whole what's the word I'm going for? The equation for this, right? The change in y over the change in x, right? So the change in y over the change in x. So the y's are the same, so there's no change, right? 5 minus 5. The x's, though, we've got -2 minus 3. So we wind up with 0 over -5, right? Now look, zeros can be in numerators, right? Like think of this. If I had no money and I divided it between my 5 kids or -5 kids, but if I had no money and I divided it between my 5 kids, they all get no money, right? So it's okay that the zero's in the numerator. 0 cannot be in the denominator because that doesn't make any sense. Like if we flipped it, it would be like if I had 5 kids, or if I had $5 and I wanted to divide it into no kids because I don't have any kids, it makes a weird, it's a glitch in algebra. That's the way I like to describe it. Okay. So it's an undefined, but because the zero's in the numerator, we're good to go. It's just 0. Okay. It's just 0. So now that's the answer for that question. But I want to run through, because this is a review, some things about this line that we know, right? I know because the slope is 0, what kind of line do we have? Put it in the chat real fast. Your guess. Because the slope is 0, what kind of line do we have? Yes, horizontal. So we've got a horizontal line, right? I could even find the equation of this line. So now we're jumping over to 3.4 stuff. If I asked you the equation of this line, right? Typically in 3.4, it said something like, what's the equation of a line that's horizontal and it goes through -2, 5? It only gave you one coordinate, right? But I could know the equation as well, because remember, if we've got a horizontal line, notice the value that's stuck here. The y value stuck, right? But if I've got a horizontal line, it's and I want to find the equation, it's always y equals, and it's always y equals whatever the y value is. So y equals 5. So that's 3.5 stuff. Oh, not 3.5. That's what it is. 3.4. Because I just wrote 5. Now the horizontal part was actually, I think 3.1 is when they introduced horizontal lines. Yeah, 3.1 is when they introduce horizontal lines. That answer your question, JL? You're not on the screen anymore. Weird. Okay. Yeah, gotcha. Okay, cool. Any other questions from the homework?
Can you do like maybe number 30 or 31 in 3.2 as well?
Yeah, sure. So same page. Yep. Yeah, 30, 31. That sounds great. And it's the same kind of setup here. Remember, we've talked about this a lot, right? I'm going to switch over to emphasize this so you can see my eyeballs. We've talked about this a lot. And not just JL and I, but the whole class. We talked about this. These are the trickier questions, yet there's less math involved, right? It's not like typical, that's kind of cockeyed. It's not like typical plug and chug stuff. Or for this one, it was fine. Was it finding the slope of the line? Oh yeah, and the y-intercept. So it doesn't fit into that nice equation as well, right? Like the whole y equals mx plus b, which if you look at this section on page 195, 21 through 30, or 21 through 42, right? It goes to the next page. They're asking, hey, find the slope and the y-intercept of each line. They give you an equation. And for most of them, you just solve for y. You solve for y, and then you know the coefficient of the x is our slope, right? And the constant is going to be our y-intercept. Now, the ones JL are asking about, though, they don't fit in that mold. Like if we looked at 30, so same page 194, let me flip over here. Same page 194, number 30. We've got x equals 7.2. Okay, x equals 7.2. And now look, we just went over this. Horizontal lines where y equals a number. Well, vertical lines are always going to be x equal number. So I'm going to just kind of write that on the side. I know this is a vertical line. Okay, I know this is a vertical line. And now the question asks, what's the slope in the y-intercept? So we know like horizontal lines have a slope of 0. Vertical lines have a slope of undefined, right? Vertical lines have a slope of undefined. So that's the first part. But then we've got to figure out the y-intercept. And this is the one that gets kind of goofy, right? If it's a vertical line, x equals energy, like in our brains, here's what I want you to do. I want you to use your noggin here, okay? Use your noggin. You can close your eyes if you want. We can get real spiritual with it. Think of the x and y axes, right? And then I want you to think of a vertical line. Now it's stuck at x equals 7.2. So remember that x axis is the horizontal line, right? Go to 7.2. Think of a vertical line there. Does that line ever cross the y-axis? No, I saw Gracie nod her head. No, or back and forth, not up and down. It doesn't, right? It doesn't cross the y-axis. And the question asked to give the y-intercept. Well, if our line never crosses the y-axis, it just doesn't have a y-intercept. So no y-intercept. No y-intercept. Okay. Now I'm going to do 31 too, because 31 actually is going to be, I think, a horizontal. Yeah. So 31. 31 is a y equals -2. Okay. Now we're kind of cheating here because it's just right there, right? But I need you to go through this in your head. If we've got y equals -2 is a slope, or is the equation, again, I know this is a horizontal line. Therefore, I know the slope is 0 because it doesn't go up or down. The slant is flat, right? We're flatlining. But now, again, I want you to kind of think in your head. If we've got the x and y axis, I'll draw this one. We won't have to. If we've got the x and y axis, so it looks something like that. And we drew this line y equals -2. This one will go through an intercept, right? Or not an intercept. It will go through a y-intercept. It doesn't go through an x-intercept. It doesn't cross the x-axis, but it does go through the y-intercept right there. 0, -2. So that's going to be my y-intercept. Okay. Where's my, there it is. Does that help? Cool. Okay. Okay, so how about this? I'm going to start reviewing, and if you have a question, you can pop it in the chat, or because this might kind of bring up questions as I'm going through it, or you are more than welcome to ask me after. Both are a-okay. But I want you to know, if I was studying for this test, this is what I would study for. Okay, this is what I would study for. Give me just 1 second. Going. I got to remember what all is in 3.1. I've got the book here, but really I'm focusing more on what's in each section. Okay, I'll tell you. If you go back to 3.1, so let's start in 3.1. In 3.1, the very first thing in 3.1 was actually about plotting points. And I do a basic plotting point question on the test, where I just ask you to plot an ordered pair or two. And it's actually one of the easier questions. But let's start there. I know none of these questions haven't been asked in a regular flipped lecture, but I know they're on the test. So we're on the in the homework. So if I had something like, I just want you to plot 0 to, or let's do a fraction just to throw it around. Let's say like 2, -3/2. Okay, I want you to just plot these two coordinates, not make a line. These are just two coordinates in space. Okay, so remember, if I plot these, let's say the first coordinate we'll plot with a red. So this coordinate 0, 2. Oh, now look, I can tell that this is an intercept because the x value is 0, right? So therefore I go 0. I don't go left or right on the x, right? Here's the x, here's the y, but I do go up 2 units. So boom, that's my red coordinate. That's 0, 2. Okay, let's do another color here. It's like green kind of color going on. So 2, -3/2. Well, -3/2, I've got to realize is really just -1.5. If you want to pop it in a calculator, you're more than welcome to. So if I was going to plot 2 -3/2, I'd go over 2 on the x-axis and then down 1.5 units. So about right there. Okay, about right there. That's where 3.1 started. Just plotting points on the x and the y-axis. Okay, plotting points on the x and the y-axis. And then it jumped into determining if solutions, or if a coordinate was a solution to an equation, or an ordered pair really is a solution to an equation. So if I had something like, let's say, I'm going to see how I worded on the test, which is going to be the same in the book because I'm stealing the question straight from the book. But let's say, yeah, determine. So we'll call this one 1, 2. Determine whether the ordered pair is a solution. So let's say I've got an equation like, actually, I'm going to steal one straight from the book. This is in 3.1. I don't have to be creative. This is like number 34 in the book. It says 5x minus 3y equals 9. And it gives us two ordered pairs. It says A, we're going to do 0, 3, and B, we're going to do 12/5 -1. That's kind of mean, but that's what it says. So 12/5 -1 and 0, 3. Well, let's do, so the goal here is we're just going to plug these in and see if they equal 9, right? Plug both in and then see if it comes out equal to 9. And if it does, we know they're a solution, right? We know they're a solution. If it doesn't, it's not a solution. So let's plug these in. So first I'm going to plug in the 0, 3. So it'd be 5 times 0 minus 3 times 3. Okay. 5 times 0 goes away, right? -3 times 3 gives me a -9 equals -9. Hey, a dog, yes. You do get brownie points for animals, by the way, in this class. So yes, Gracie is the first to snatch the dog or the pet brownie point. Okay, Gracie, hold on. Wait, we know this isn't a solution. What is your dog's name?
Her name's Sophie.
Sophie? Nice. What's up, Sophie? What's up, buddy? Can you? Oh, you can't see me. I'm waving at the camera and you can't see me. What's up, Sophie? Sophie looks kind of
She
grumpy.
decided to join me.
Huh?
She
What did you say?
decided to join me.
Nice. Yeah. Okay. So now let's do the 12 is -1. So I'm going to say 5 times. You know what? I don't know what 12 is. I'm going to put, I know if you divide anything by 5, you get a nice decimal. So I'm going to be efficient here. And I'm going to say 12 divided by 5. Oh, that's just 2.4. So I'm going to plug it in my calculator that way. 5 times 2.4 minus 3 times -1. And I want to know, is that +9? So I'm just going to take my calculator out and do this. So 5 times 2.4, not 20.4, but 2.4, minus 3 times -1. I got +15. Check me here. See if I put this in right. 5 times 2.4 is 12. This will be +3. Yeah. That doesn't equal 9 either. That's 15. So that's a no solution too. And that's fine. They can both be no solutions. Okay. Questions on that one? And I'll tell you, this is a nice way to check your answer. We're going to go over that actually when we get to like 3.4. It's a nice way to check your answer in 3.4. We'll get there. But we got to go through 3.2 and 3.3 first. Okay. Questions, comments, concerns? I'm going to keep rocking and rolling actually. So I'll leave that up there for a minute if you're writing it down. Oh, then we got to 3.2, which was on slope, right? So 3.2 was on slope. And the very first thing I believe it starts with is just finding the equation, or not finding the equation, but finding the slope given to coordinates, which JL asked me about earlier. So we already did a good example with the horizontal line. So I'm going to try to find one with just a more traditional, 2 coordinates, and you find the slope. So give me just 1 second. I'm going to steal one from the book. Yeah. So let me take this. Okay. So let's say we've got, this is number, I'm going to do an even one. This is number 6 on page 194 from 3.2. Okay. Number 6. So 3, 7, -2, 11. I might have done this one already, but that's fine. So the question will say, find the slope of the line containing the pair of points. So you got these pair of points and you need to find the slope. So we know we're going to subtract the y's first and then subtract the x's, right? It's the change in the y over the change in the x. So 7 minus 11, right? Over 3 minus a -2. So 7 minus 11 over 3 minus -2. Well, 7 minus 11, that's a -4. Yep. And then I can do my lazy trick here, right? 2 negatives make a positive. This is 3 plus 2. So it winds up being a +5. Hey, that's it. We found the slope of our line. So this means we're going to rise -4 and we're going to run a +5, right? If we were going to graph it. But that's not what this question asks. It just asks to find the slope. Okay. That's a good question. This is number 6. So if you go back and do the homework and you're wanting to kind of find one to know the answer for, number 6. Another one, and remember, I remember doing this one in class, but it's going to be like the questions 13 through 16. I'm going to make one up. So if I give you a line, I want you to find the slope. I think we did this one a few days ago. So let's say I've got a line and it goes through -1, 2. So that's -1, 2. And it also goes through, and let's do 3, 1. 3, 1. I'm giving you the coordinates because sometimes this doesn't look perfect, but so -1, 2, and 3, 1. Okay. So here is my line. Well, first off, I can tell it's going to be negative, right? Because it's going down and to the right. But if I asked you to find the slope, I've got to use that whole rise over run thing, right? Rise over run. So if I want to go from the left point to the right point, I know I'm going to go down 1 unit. That's going to be my rise. Down 1 unit. And my run's going to be, well, 1, 2, 3, 4. It's going to take me 4 units to get to the next coordinate. So my slope is -1/4. Okay. -1/4 because I went down 1 and then to the right 4 units. Okay. Any questions about those two? We're going to do some more. 3.2 kind of had a lot of stuff going on, actually. 3.3 was the shortest section. Okay, let's see here. Any questions, comments, or concerns? Okay, so next it's going to be
I got a question.
Oh, I'm
Sorry.
listening.
So when we do the quiz, does it want, if the line is going down, do they necessarily want the negative sign in the numerator, or?
Oh, yeah. Well, and I'll tell you, I think this test is going to be a lot more multiple choice, so you won't have to worry about that. But your book puts it out front. So I'm glad you said something about that. Yeah, your book puts it out front, and I snag these questions straight from the book to keep it consistent. So yes, that's a good question, Gracie. Remember, -1/4 is the same as -1/4. Now, if we were taking this test in my class, I wouldn't mind which one you put down because they're both correct, right? You know that because you were asking that question, which is awesome. Okay, so the next one is pulling the slope and the y-intercept from the equation, right? So if I gave you, let's do like kind of a basic one. Let's do like number, let me see, I say a basic one and I don't see one I like. I'm going to make up one. This is like it's objective B and C. So like numbers 21 through 42 in 3.2. But I'm going to make one up. So let's say I had y equals 4/5 x minus 8. And I want you to just tell me the slope. And I want you to tell me the y-intercept. Right? Tell me the slope, tell me the y-intercept. And hopefully at this point, this is the easy stuff. You're like, oh man, gosh, yes. I hope there's 10 of these questions out of I think there's 18 total. Okay. So visually, the coefficient right here, 4/5, we know has to be the slope, right? And then the y-intercept. Now, you're going to have to think of the y-intercept, either write it or choose it. It's going to be written as a coordinate. So remember the y-intercept, the 0 comes first, and then you have the actual b value. So for us, it's -8, right? 0, -8. So y-intercept, easy. Easy peasy, right? Hopefully. I mean, we've done a lot of this stuff so far. And this was 3.2, but it popped up in 3.3 and 3.4. Oh, man. Okay. Now I'm not going to do I'm not going to do a horizontal or vertical because we did that at the beginning of this lecture recording. But remember that's on there, right? So make sure to know how to grab the slope and the y-intercept from vertical and horizontal lines, like we did at the beginning of this recording. But another one would be something like 2x minus 3y equals, let's say 5. So this would be like, oh, that's number 6. I haven't really been counting these. No, these are just made up numbers at this point. But if this was an A and this was a B, okay? If I gave you this equation and I asked the same thing, I want the slope and I want the y-intercept, same 21 through 42, you'll see that in that homework. Well, now we have to solve for y. We got to solve for y, so we have to manipulate this equation into what we want, right? So we've got to solve for y. So first I'm going to subtract the 2x. We get negative 3y equals negative 2x plus 5. And then lastly, we've got to divide the negative 3 to everything. Right? We have to divide the negative 3 to everything. So when I do that, and I'm going to write it up here because I'm running out of space, I get my y by itself, which is what I have to have for this to work, right? Y equals, now look, the negative and negative only in math turn positive. And then we've got a minus 5/3, right? So 2/3 x minus 5/3. And then look, now I've got an example just like the one before. If I want to find the slope and the y-intercept from this equation, I know the slope is the coefficient of the x and the y-intercept is just 0 and then whatever the b value is. So this is my y-intercept. Kind of ran out of room. Okay. These are good questions. They're definitely going to pop up on there. Any comments, any concerns? Okay. Let's see if we need to do any more. Oh yeah, the parallel perpendicular stuff was in this section as well. Okay. The parallel and perpendicular stuff. And you know what? I'm gonna give you this, so I'm gonna give you a minute to figure this out. I'm gonna give it to you like a quiz. So I'm gonna steal one straight from the book. This is number 58. So in 3.2, number 58, it's on page 196, and it says, determine whether each pair of lines is parallel, perpendicular, or neither. Negative 2x plus 3y equals 1, and 3x plus 2y equals 12. So I'm going to give you a minute, and I want you to determine if these two lines are parallel, perpendicular, or neither. I'll give you 3 minutes to do it. And it's okay if you're not done. You'll see if you're on the right path. Ooh. Okay, keep working if you work. Keep going. I know this one's not the fastest question. but I've got two equations here. I need to find the slope of both because the slope tells us if we're parallel or perpendicular or neither. So on the first one, and on both of them, I'm gonna have to solve for y. So let's look at this first equation. Negative 2x plus 3y equals 1. Add the 2x. I get 3y equals 2x plus 1. Then divide the 3. And I get y equals 2/3 x plus 1/3. Okay, that doesn't tell me anything yet. I know the slope though, it's 2/3 and then y-intercept, but it doesn't help me answer my question. I've got to solve for the second equation to really answer this question. So 3x plus 2y equals 12. So first subtract the 3x, and I get 2y equals negative 3x plus 12, right? And then divide everything by 2. And I get y equals negative 3/2 x plus 6. Okay, so an easier question for the section would have given you both of these in slope intercept form, right? But now we've got to look at, let me use another color. Let me use a highlighter and see how this works. We've got to look at the slopes here, right? Looks kind of cool. Nah, that doesn't show it that great, but let's look at the slopes there. 2/3 and negative 2/3. First off, they are not parallel, right? Remember, parallel, these two had to be the exact same. But it looks like they're perpendicular. Remember, with perpendicular, you flip it and change the sign, and you have perpendicular lines. And that's exactly what's going on here. 2/3, negative 3/2. We flipped this fraction and changed the sign, and boom, we have the other slope. So these are perpendicular. Okay. Now, if this would have been let's say a positive 3/2, it would have been neither, right? Because it's not parallel, it's not perpendicular, because it didn't change signs. Or if it was just some random number like 7, it's going to be a neither as well. But these two are definitely perpendicular. Okay. Questions? Okay, I'm gonna choose one more from this section that I like that might be on the test. And it's actually kind of doing one backwards. It's like 40, it's kind of like 43 through 46, but it's matching the equation with a graph. But I'm going to give you a graph, and I want you to give me the equation. So this is, I'll call it a bonus question. It's not bonus per se. You're not going to get extra points for it, but it's an extra question from this section. Really, I think it's from the next section, actually. But I like it. So I'm going to graph a line, and I want you to think about this, and I want you to give me the equation of this line. So the line goes through 0, negative 2, and I'll give you the two intercepts. And 1, 2, 3, let's do 4. 0, 4. So there's the line. We know it goes through 0, negative 2, and 0, 4. And I want you to give me y equals mx plus b. So I want you to think a minute what you need to do that and give me y equals mx plus b. I'll give you 1 minute to do this. Okay. Now look, there's two things I need for this. If I'm given a graph, I need the slope and I need the y-intercept. Right now, the y-intercept's the easiest of the two. Visually, I can pick that y-intercept out. It is 0, negative 2. So I know my b is going to be -2. Now I've got to find the slope. Now, you can either do the rise over run method or you can do the equation because we know 2 lines. I'm going to do the rise over the run method. The slope to go from the left to the right coordinate, I've got to go up 2. So that's my rise. And then I've got to run 4. 1, 2, 3, 4. So it winds up being 1/2. Hey, I know both things I need for this equation. Y equals 1/2 x. Oh, not plus. I'm going to have to just rewrite that. It's going to bother me. Y equals 1/2 x minus 2. Pretty cool. Okay. Y equals 1/2 x minus 2. So visually, we can get this equation if we can see where it crosses the y-intercept for the more important part. We have to know where it crosses the y-intercept, and we also have to know 2 points that lie on it. And we don't really have to do much math per se. We don't have to remember an equation, like the slope equation or anything like that. We can just visually get this equation. Kind of neat. Okay. Let's keep rocking and rolling. 3.2 was really more of just the graphing out of slope intercept form. So if we looked at, let's say number 14. This is number 14. Now we're in 3.3. Number 14, it starts on page 203. Okay. And the question states, graph each linear equation using the slope and the y-intercept. So y equals, well, we didn't graph using a table, did we? Dang it. That's okay. I might go back and do that. 3.1, I skipped right over how to graph and use a table. But let's graph this point in the slope and let's graph this line because we know the slope and we know the y-intercept. So let's graph this thing. X, we've got y, right? And then I know it starts at -2. Hey, that's just like the example before. Let's see what color. It's time to change it. Dig into my. Oh, I've got a bunch of red, so we're going to use red. So let's do this. So if I wanted to graph this slope and y-intercept, knowing that the slope is 1/3 and the y-intercept is -2. Okay, so I'm going to start at -2. It's right there, right? And my slope tells me I need to go up 1 and then over 3. Right there, right? So there's my other coordinate. And I just connect the dots. Boom. Okay. Now I'm going to tell you, I know on this question it's multiple choice to make it consistent to grade. So realize you're going to have like 4 graphs and you're going to have to choose which one matches the one that is that equation, right? So it's more of a matching. You don't necessarily have to graph it. And that just makes it easier for me to grade when it comes to this stuff, okay? Because sometimes our graphs are very wild and all over the place. And it just makes it a little easier. Okay. So let's do one. And this was a comment I remember you guys asking me on that day that we went over this section. What if we had something like y equals 1/2 x? Y equals 1/2 x. Now remember, I'm just going to work this one out. It doesn't look like we have a y-intercept, but we do, right? We do have a y-intercept. The y-intercept is just 0. So if it's not written, it means it's just 0. So we've got x, we've got y, and we know that this line, to start the graph, the line has to go through the origin. And then we know the slope is 1/2. So just like before how we went up 1 over 3, now we're going to go up 1 and then over 2. And we're going to have our other line. Let's do this one in green because I can. No one's stopping me. Okay. Okay. Questions about those? And then now I know this is more of a 3.1. I don't think they asked in this one, but let's just throw in, y equals 2. I know I did that one earlier, but it's always good to have review. You try this one. Try y equals 2 and then do x equals -3. Try those two And you can put them on the same graph if you want. However you want. Just to make sure that you've got these down. This is more about a confidence building exercise at this point. Okay, so y equals 2. I remember that's a horizontal line. And so we're going to go through the y-axis at positive 2. Boom. Right? There is y equals 2. And then x equals negative 3. Vertical line. And remember, we go through the x-axis at negative 3. Okay, looks like that. So I think we did those earlier at the beginning of this section. You guys, or beginning of the lecture, you guys asked me about the vertical and horizontal. I went over them, but just to bring them back up. Okay. That was 3.3. Now, the very last section, which if you've done the homework and you've watched the lecture, you guys know, I think the last section is the toughest because it really kind of brings in some concepts that are more than just one-step solving. Like all of this was one-step stuff, right? Everything on this page was in one step. Like, oh, I know the slope of the y-intercept, plot the slope, graph the y-intercept, or plot the y-intercept, graph the slope. It's really, I guess, 2 steps, but it's a quick answer. 3.4 though isn't. 3.4, you've got to really you've got to know the equations and find the answers. And let's look at a basic one. I know we've done a lot of these already, but I'm going to steal a basic one from the book. Let's say actually, no, let's not steal a basic one. Let's steal a fraction. Let's say number 6. It's 3.4 now. This is number 6. Our slope is 2/3. And we know it goes through negative 9/4. Or not negative 9/4, not negative 9/4. The question states, write the equation of each line with a given slope and containing the given point. Write the equation in slope-intercept form. So we want to write it in y equals mx plus b. So I'm going to give you a minute to work this, okay, to see if we're in the right spot. And if you've done the homework, you've seen, I know you didn't do the evens, but if you've done the homework, you've definitely seen one like this. I'm going to give you a minute to work this, and then we'll go on to a few that kind of build on it. Okay, let's start this one. It's okay if you're not done. It's just so I can fit in these last few before we're done with last time. We've got, remember, if we want to get it in this form, if we're given a point and a slope, we need to put it in point slope form first. So y minus 4 equals 2/3 x minus a -9, right? So we put it in point slope form first, and then we solve it for y. So to solve it for y, now look, I'm going to do that lazy thing again and make that a plus, and I'm going to distribute the 2/3. So I get y minus 4 equals 2/3 x. Now, 2/3 times 9, remember this is 9/1. So 2 times 9 is 18. 3 times 1 is 3. That's actually going to be a nice number. 18 divided by 3 is just 6, right? So we get y minus 4 equals 2/3 x plus 6. And then now we've got to move the 4 over to finally get the y by itself. And we get y equals 2/3 x plus 10. Cool. I mean, that was a lot of work, right? Now you could have kind of skipped a few, just pop this in the calculator, like 2/3 times 9, you would go back 6. You could have gone to here, something like that. That's fine. But now the question is, I don't feel that confident, and I'm not sure if I'm right. How do I know I'm right? Well, look, there's only 2 things that have to be true. It's got to have a slope of 2/3, and it has to go through -9/4. Now, if I gave you this equation, hopefully you can see that it has a slope of 2/3, right? There's a 2/3 coefficient. That checks out, right? Now, if I want to know if it goes through -9/4, I can plug that in. Remember, that was the very first thing we went over today, plugging it in. So I'm going to do this on the side over here. And I'm going to plug -9/4 into this equation. So this would be, I want to know if 4 equals, because that's the 9, 2/3 times -9 plus 10. Well, I know 2/3 times 9, we did that just a second ago, right? And it wound up being 6. So 2/3 times -9 would be -6 plus 10. Oh, that works out, right? -6 plus 4 is definitely, or I'm sorry, -6 plus 10 is definitely 4. So these 2 things are true. So this has to be true. This equation has a slope of 2/3, and it also goes through -9/4. Neat. Okay, pretty cool. Okay, let's do one from the that brings up the parallel perpendicular concept. The parallel perpendicular. I'm going to steal it from the book too. Let's say we had a question like number, I'm going to do one that's a little easier than they give you in the book or in the homework. Yeah, I'm going to make one up. This is like 25 and 3.4. It's like 25 through 36, but I'm going to change it a little bit. I'm going to say we go through, let's say -1, 2, and we're perpendicular to y equals 2x plus, I don't know, let's say 5. Okay, y equals 2x plus 5. I'm just going to work this one out with you because we still have a little bit of time, kind of running out of time. So y equals 2x plus 5. Now look, we've got to be perpendicular. So we need slope and we need a point to put in our point slope form, right? Now this is not our slope because we're perpendicular. If it was parallel, it would be our slope. The 2 would be our slope. But our perpendicular slope, remember, 2 is 2/1. So really we flip it and change the sign. So it's going to be -1/2. And we know our coordinate is -1, 2. Oh, that's crazy. They're the same numbers, but that's fine. That's not a big deal. That's just a weird coincidence. So now I want to plug this into point slope form. Now I'm going to follow the same exact rules or same exact kind of steps from the previous question. So y minus 2 equals -1/2 times x minus a -1, right? And again, that x minus a -1, I'm going to be lazy here, it turns positive. And we want to get it into y equals mx plus b. I didn't say that at the beginning, but we want to get it there. On the test, you're not going to have to do the standard form. Just y equals mx plus b for the answer. So we get y minus 2 equals negative 1/2 x. Now, negative anything times 1 is itself, right? So negative 1/2. And then lastly, I've got to add 2 on both sides. So I get y equals negative 1/2 x. Well, if I've got negative 1/2 and I add 2, so if I've got like negative 50 cents, right, and I add $2, we got $1.50. Now, in fractions, that's 3/2, right? I've got 3/2. Okay. So I'll wind up with 3/2. And again, if you're like, I'm not sure how to check this, how would I know if this is right? Well, if I gave you this equation and I gave you what we found our equation to be, and I said, hey, are these two lines perpendicular? You're going to reach back to 3.2 and go, yeah, they are, because 2 and negative 1/2 are perpendicular lines, right? So that checks out. We are perpendicular to y equals 2x plus 5. Now, do we go through negative 1, 2? Well, this is going to take a little more time to check, but I'm going to check this one, okay? So this is me checking. So 2, is that equal to negative 1/2 times negative 1 plus 3/2? It's 2 equal to, now, negative 1 times negative 2, that's positive 1. Well, 1/2 plus 3/2. Oh, yeah, 1/2 plus 3/2. Remember, common denominator, add the numerators. This is 4/2. That checks out, right? It does check out. It does go through negative 1, 2 because of what we learned how to do in section 3.1 on is this coordinate a solution to this line? Yes, it is. Okay. The crowd goes wild. We did it again. Okay. I'm going to flip back over to me. That's a good review. I'll say that. That's a really good review. If you have any, like, you got me for 15 more minutes, right? And I won't, gosh, I really need to trim this beard. It's getting woolly. Any questions? Sit, think about it. It's fine. We got time. Any questions? Okay, and I'm going to tell you, the next 2 days, I know I have office hours on my syllabi from 9:15 to 11:15, but I'm going to be pulled into like 4 meetings over the next 2 days during those times. So if you want to come see me to ask questions, just shoot me an email to let me know I'm here, and it sets aside that time for you. Or if I've got another student, you might want to wait too. But just let me know. It's no big deal. And even if you can't meet at those times, I am typically on campus till about 3 o'clock every day. Okay. So even though my office hour says 9:15 to 11:15, I'm usually available. You know, I'll take lunch, right? But I'm usually available all day until 3. I usually have to pick up a kid, or I've got an afternoon meeting, things like that happen. So it's no big deal. If you want to come to my office outside of those times, that's not a big deal at all. Okay. I'm going to stop the live stream because future students really don't probably care